One of the great advantages of teaching in homeschool is that we can do hands-on learning. But how? I just want to go over a couple ideas of how to do it in math and science today. The first year I started homeschooling, I was in charge of teaching the 8-year-olds through the 11-year-olds science and math. And I really wanted to teach them in a hands-on and engaging way that would keep their interest and let them learn in ways that they couldn't get in a more traditional setting. So I've just gathered up a lot of the things that I did with that group, and I'm going to run them by you today. Okay. First off, I did not do this with the group, but it was super effective. Where we lived before, our local university had what they called as Super Science Saturdays, and they were amazing. They opened up their whole science department, so we got to go see skeletons of dinosaurs and lots of rocks, and we had gravity things that they were teaching us. They had a planetarium that we could go in and watch a show in the planetarium. They had classes that they taught, and they did hands-on stuff for the kids. Really fascinating stuff. It was all free, and it was just available to the public, but I don't know if my husband didn't go to school there at the time, if I would have known about it. So check out your local universities. They may have science stuff that they offer all the time for free. I am so glad that we found out about that because it was a really great experience for us however often they did it. Okay, so I want to start with math. The first thing that we did in math that was super effective was just buy an abacus. And I don't know if you've seen an abacus, but it's so simple. It's just a little plastic frame, and they've got wires, about 10 wires across with beads on them. And when I first looked at that, I thought, are you kidding me? This is so old and there's no way that this is useful. But I heard that it was a really great tool, and so we got it, and my kids used it to do math on it. And at one point, I remember talking to my son and saying, hey, can you do this math problem? And he did it on the abacus, and then he said, this isn't hard. He was like, I don't even understand what this is all about because the beads tell you what the answer was. And I thought, oh, that's why you use the abacus, because it makes it so visual and so obvious. He didn't even feel like he was doing a problem. He was like, I'm just looking at the beads and that's what the answer is. And this kid has amazing number sense. I don't know if he would have had number sense on his own if we hadn't used the abacus, but I'm telling you, he definitely did, and the abacus, I think, really helped with that he could visualize, and then also he used his body to move things across, so he could say, well, 5 plus 2, and he could see how those work together to create 7, and he actually made it equal 7 as he moved them across. So buy an abacus. It looks old, it looks like a crazy old idea, but I'm telling you, it is super effective as a hands-on tool for understanding math. And the next thing that I did with a group was that I took a bunch of pieces of paper, just like construction paper, and I wrote 0 through 15 and then -1 through -15, something like that. And then I would have the kids start standing on a piece of paper, say -7, and we would say, okay, so -7 plus 6 is what? And then they would just walk up 6 papers so that they would go up, and they'd say, oh, it's -1. And then we would have them go up and down, plus this, minus this, whatever, so that they could get used to the idea that wherever you started, plus means go up the number line and minus means go down the number line, because a lot of kids really struggle with the idea of what's -6 minus 3. That's how many minuses, and I don't understand, and what are we doing? And this really helped them visualize. You start on that first number, and then you go up if you're adding, or you go down if you're subtracting. And it was a very hands-on, physical way to be able to figure out the number line and how those numbers interact with each other. The next thing I was teaching was the importance of units when you had measurements. And so if you say 3 plus 2, you can come up with 5, but 5 what? Is it 3 apples plus 2 apples, or is it 3 inches, or is it 3 pounds? What are we dealing with? And so to teach this concept, I gave the kids a recipe with all the numbers, but none of the measurements. So I said, 2 baking soda and 3 flour. And they just had to sort of figure out on their own what they were making, what they had to use. And so I gave them a whole bunch of different measurements to use. We had teaspoons and tablespoons and cups and whatever. And I just said, okay, here you go, make this recipe. And they did remarkably well, because they had a basic idea. You didn't put in cups of baking soda, and you did put in cups of flour. So in the end, it was actually edible, but it really, I hope, enforced the idea that you needed to not only have numbers, but you needed to have units, because that really affected what you were getting as an outcome. One of the most intensive preparation ones I did, but I also felt was really successful, was I had a big long list of a bunch of different ways that we have energy, different types of energy. Things like nuclear energy, mechanical, electrical, chemical, heat, magnetic, solar. These are all different types of energy. So I had pieces of paper up on the board with each of these types of energy. Then on the floor in a semicircle, I had something that represented each of these types of energy. And they had to hook them up. They had to say chemical energy went with the plate of food that I had. And then once they had matched those together, then I would have either a video or an activity or something that we did to be able to connect that idea of how that chemical energy worked. So I'm just going to go through the list of the different things I had. I set up a radioactive sign for nuclear energy. That one was pretty easy. And I don't actually remember all the things I did to explain this. There were probably videos involved or something. Then I had a teeter-totter, which was so simple. It was like a cup with a tongue depressor taped to it, right? So I'm not putting a ton of energy into this, but that was mechanical energy as we go up and down so that they could understand that when something physically moves, it creates mechanical energy. And I remember with that one, we actually watched a video, Devin Supertramp made the video, and these guys were jumping, and I honestly cannot remember if they were jumping on a teeter-totter. I wonder if that's why I used a teeter-totter, or if they were on a tramp, but I remember that they just went really, really high, and showing what you could do with that mechanical energy as you went up in the air, and they did these amazing tricks. And so that was how I explained what mechanical energy was. The next one was such a disappointment for me. It was electrical energy, and I had this just amazing ball that when you plugged it in, it would have this static or electricity that goes on it, and you could put your hand on it, and it would, you know, all the electricity would go to your hand, and it looked so cool. But the day I was teaching this, I put it in the back of my car, and it was really cold, and the glass bulb just couldn't handle the cold, and it shattered before I even got there. So I assumed they would have thought it was really cool, but we'll never know. But I think it would have been really cool had it survived the trip. Then I had a plate of food, I think a sandwich or an apple or something for chemical. And then I just had a plate that had a couple of pieces of ice on it. And those pieces of ice were melting. As you know, the class is going on and we're explaining all these different types of energy. It's just melting, melting, melting. And that was to explain thermal energy and how it was changing the state of that ice. So then I just had the kids come up and take turns choosing that paper and deciding which one it went with. And each one had something, you know, we did a video with it, or we did some sort of a discussion with it, or an explanation of how it worked. Maybe we'd go into the breakdown of food and how that becomes chemical energy. And I had a couple of hours to do this particular class. So I was able to do quite a lot with each of them. But that's just one way that you can take something that maybe can be boring and turn it into a hands-on lesson. So for another lesson, I was teaching natural law, and natural law actually has to do with the way that humans interact with each other. So we're talking about things like being honest or treating other people the way that you want to be treated. That's natural law. But there's also kind of a scientific natural law, and you're dealing with the laws of science, gravity, stuff like that. And to teach this, we did an egg drop. And there's lots of different stuff you can go online to figure out, well, these are the rules, you know, it can only be this big, or it has to be dropped from this height or whatever. But the point is, you've got an egg and it needs to be encased in something that will protect it so that when you drop it off of a height, it will not break. And so that was teaching the law of gravity. And at the same time, we had helium balloons there to say, why do those go up when the eggs come down? And so we use those as visual aids to explain how gravity works. For that same lesson, we also built houses using toothpicks and marshmallows because there are structural laws in nature to understand how things need to be put together so that they don't fall. You know, you can't have an entire house that is balanced on its tip. You have to have a really strong base and foundation before you can start doing arches or domes or whatever. You need to have that foundation in place, and that's a natural law to understand that you've got to have that foundation. So that's one of the ways that we taught that. This next one might have been done in conjunction with the energy one. I don't remember, but I wanted them to understand that when we eat food, it actually gives us energy to do things, to take action. So I gave them, I think it was a Snickers bar, but you could be a little more healthy and just give them like a slice of an apple or something, and then ask them to do several things. So I had them in a relay race, and I said, okay, first person, we had them like bear crawl and then crab walk and hop for 1 minute, and they did a grapevine. That was actually dangerous. I remember watching the kids do grapevine as they went from one side to the other and thinking someone's gonna get broken, but we made it, it was okay. One of them, we had them run on tiptoes. They did jumping jacks. And so what you could do in this situation is go and figure out how many calories each of those activities burns. And then you'd say, okay, that apple gave you this many calories. You burned this many calories doing this energy, so that they can connect the idea of the food we eat gives us the energy to do the things that we do with our bodies. And the last one that I did that was just a huge hit was that I was teaching Newton's third law of motion, which is for every action there is an opposite and equal reaction. And so in this case, I started off by asking them, can you think of anything where you see Newton's third law? And I just gave the example of a scooter. When you stand on the scooter, you push your foot backward, and the opposite and equal reaction is that the scooter goes forward. And so once they had that in their mind, they were able to say, oh, cars do that. You know, the wheels are going to be pushing backward, but the car itself actually goes forward. And rockets do that when the rocket is pushing down on the earth, but actually the rocket itself is going up. So it's finding all of these real life examples of this law of motion. And then we created cars, little balloon cars. I don't know if you're familiar with these. But basically, we used straws to make a framework for this car. So we had 2 straws for the axles, and the ends of the straws had lifesavers on the end of them for the wheels. And then we made a little paper frame for the car, and coming up through that was a balloon. And you would blow up the balloon so that the opening to the balloon was pushing backward. So when you let go of the balloon, all of the air came out of the balloon and it pushed the car forward. And this just enabled the kids, they were so creative and they had so much fun creating this, and then also seeing that it used Newton's third law of motion. So that's another way to do hands-on explaining a concept like the third law of motion. And there are a ton more ways to do hands-on stuff. Mostly my challenge with doing hands-on stuff is that it takes energy, and I don't want to put in the energy to do the preparation. So a lot of times this works really well in a group when I am accountable to show up for the group. So I will put in the energy for them. So a lot of times this level of stuff works better in a group for that reason. But whether you are really motivated and you do it in your own house, or you go and work with another group, whether you teach it or not, doing these types of activities makes the experience stick in the kids' head, and the knowledge is accessible to them years in the future. They may look back and be like, oh, I didn't realize that was about Newton's third law of motion, but now that I have some more experience, I can look back and say, oh, I can tap into that and connect those ideas a little bit stronger because the experience stuck in my head so much from doing something fun when I was that age. So I do encourage lots of hands-on learning. It's a lot of fun, and it just sticks with them for a long time. I hope that helps. I hope you have a wonderful week, and I will catch you on the next one.